business manual for that. About the step down.
Screen is visible.
Did you know about the step down? So according to
Hello.
how to convert the high voltage to the low voltage in that case that is called as step
Visible
down.
है क्या screen?
Voltage that is low to the high which is converted then the step is called as step up, right?
Yes, sir. Yes, sir.
Okay.
You have to use the step down type of the transformer, right? So step down type of the
So in the
transformer.
previous class we have discussed about the CRO, that is cathode ray oscilloscope we have discussed. So the next part of the oscilloscope that is called digital storage oscilloscope, that is called DSO. Today we are going to discuss about this DSO here now. So the digital storage oscilloscope, it is also an instrument. I told that yesterday that the whatever the values we are going to show, that it is going to the digital storage, the name came here now, in the memory, or we can connect it to the computer. It is going to store the value of that. So that value, whatever the magnitudes and phases are there, it is going to store here now, and it is also going to display. For that reason, the name came digital storage oscilloscope, name came here now. So here the digital storage oscilloscope is an instrument which gives the storage of a digital waveform or a digital copy of the waveform here now. So it is going to give the storage of the digital waveform, also the digital copy of the waveform it is going to give over there. So second point, it allows us to store the signal, whatever the values it is going to show over there, it is going to allow us to store the signal and the waveform, whatever the waveforms is there, in the digital format. In the digital format means whatever the values, the analog values or signals we are going to use like this. Okay, so this one, suppose this value, what is the peak to peak value? What is the this value here now? This in the digital forms, the number it is going to give for a particular time period. The number it is going to give for particular time period. So then we can store that digital value here now. So waveform in the form and the digital format we are going to store here now. And in the digital memory also it allows us to do the digital signal processing techniques over the signal here. So by using the digital signal processing, it is going to store its digital value over there.
Plus minus voltage is coming across it. So due to that plus voltage that doing it.
So next we'll go for the block diagram. We'll go for block diagram. We'll go. I think system is this is the block diagram of digital storage. Here also we are going to use that CRT tube, we are going to cathode ray tube we are going to use, but whatever the signals we are going to put on the vertical plates and horizontal plates, we have to convert that one and amplify that, and we are going to give that one. See here the input signal we are going to take. That input signal is amplified here. Now the amplifier signal blocks, what it will do, the input signal, it is going to amplify that one, and whatever the magnitude is there and for how much period of time, or this is for the vertical axis and this is for the horizontal axis here. So this will separate its two path, it is going to separate here. So this input is first in the vertical path we will consider, it is going to digitize first, then that value it is going to store in the memory, it is going to store in the memory, then that value whatever the stored here, it is analyze that one first. The analyzer circuit, it is going to analyze that, then if any reconstructions are required for these waveforms, then it is going to reconstruct that one, reconstruct, and it will go to the vertical plates, it is going to apply that one. Similar way for the horizontal, but horizontal it is the time base is in the x-axis. All of you have seen that one. See this y-axis, it will give the magnitude, but the horizontal one is nothing but we are going to use time only. Yes or no? Omega t are only time we are going to use here. No, so here we are adding the clock here now. So based on time, here the trigger circuit we are going to use, it is trigger with time, it is give the horizontal amplifier will amplify that signal and it is going to apply here now. So whatever the arrow mark we have used in the diagram, it is wrong actually. See here the arrow mark of this one will be like this, in this side it is there, so this is not correct here now. The textbook also it is given in the reverse, that is not correct. So trigger and clock both will give the time base. From the output of this time base we are going to get the time, that which will apply for the amplifier, that is horizontal amplifier, it is going to amplify the signal, the x-axis signal, and it will give to the horizontal plates here. Now this CRT, it is going to display that part here, it is going to display that part. So this is the simple block diagram of the DSO, digital storage oscilloscope. Okay, so next what we'll do, we'll go for, so the block diagram of the digital storage oscilloscope consists of an amplifier, digitizer, it is amplifier is amplifies the signal, and digitizer, it is going to digitize analog to digital, and the memory, it is going to store the signal, store the signal, and the analyzer will analyze the circuits over there. It's going to so the memory circuit, it is going to store the value, and the analyzer will, it is going to analyze the input signal, whatever which one converted into digital, that it is going to analyze. Who is Pramod Korke? Pramod Korke. Pramod Korke. Korke Pramod, what is your roll number? Pramod Korke. What is your roll number? Otherwise, I will remove you from the meeting. Pramod Korke, are you there? एक बार मैंने रिमूव किया ना, वापस ज्वाइन होने के लिए नहीं होते. प्रमोद, okay, so here digitizer, memory and analyzer circuit. The waveform reconstruction and vertical plates, horizontal plates, CRT tube, horizontal amplifier, time-based circuit and clock trigger. It is going to pass the signal here. Now it is already shown in the DSO block diagram. So at first what it will do, the digital storage oscilloscope digitizes here. Now it is going to digitize the value. It is going to identify the value over that. So analog signal to the digital, it is going to digitize us the analog input signal. Whatever the input signal is given analog, that one is converted into digital. Then the analog input signal is amplified by amplifier. That is small signal to the bigger value. It is going to amplify here. So whatever by speaker I have example, I have given already that one amplifier here. No, if it has any weak signal, if the signal is weak, then we are going to amplify that one. Otherwise, as it is, we are going to give that one here. After amplification, what will happen? The signal is digitized by the digitizer here. So digitize. So amplification again it is digitizer will digitalize and it is going to store in the memory circuit here. It is going to store in the memory circuit. So the analyzer circuit, it will process the digital signal after that waveform is reconstructed here. It is going to analyze and it is going to reconstruct that one. Again, digital signal is converted into analog for the reconstruction over there, because we have to apply to the CRT here now. So again, the digital signal is converted into analog and then signal is applied to the vertical plates of the cathode ray tube. So for the storage purpose, we have to digitalize. Then we have to apply for the CRT. Again, it should have to convert into analog over there. So the CRT tube has two inputs. They are vertical inputs and horizontal inputs are there. Vertical inputs and horizontal inputs. So the vertical input signal is y-axis. So already all of you know that one. This is y-axis is nothing but vertical and x-axis is nothing but horizontal here now. So the time-based circuit is triggered for the vertical horizontal axis here now, triggered, and clock input signal here now. So it is going to generate the time-based signal, which is ramp signal here. It is going to generate the time signal here now. Then that ramp signal is amplified by the amplifier by the horizontal. So due to the internet connection, it has disconnected. I will once again show that one where and slideshow. Is it visible? Screen? Screen is visible. Once again, have shared that one. Yes or no?
Yes, sir.
Okay. So what will happen? That ramp signal is amplified by the horizontal amplifier. It is going to amplify if the signal is weak. Then the output will provide to the whatever horizontal amplifier will provide the input to the horizontal plate. So now both horizontal plate and vertical plate, the input will came. So the horizontal plate, it is going to display the amplitude of value and that magnitude of that value, and vertical horizontal plate, it will display the time base, and vertical it is going to give the magnitude over there. So both the plates, it is going to display the signals over there here now. So on the CRT screen, we'll get the waveform of the input signal versus time over there here now. So for the horizontal axis, it is going to give the time input here now, and vertical axis, it is going to give the value, that is, it is going to whatever vertical plates it came, this one it is going to give, horizontal plates, it is going to give this one here now. I will show that one, how it is going to give that value also, I will show that one. So the digitizing occurs by taking sample of the input waveforms. Whatever the digitization is there before storing to the memory unit, so it is going to occur by taking sample of some input they are going to take over there. So at the periodic time interval means when the half of the time cycle is completed, then we are taking a sample of the signal. For one cycle, we will not wait for that one. Once the 0 to 90 degree, the time or some half before taking to the complete half cycle, how much time it will take to complete for high half cycle, on that time only the time cycle is completed, then we are going to take the sample of that signal, we are going to take that one. So the process of digitizing or sampling should follow the sampling theorem here. It is going to follow the sampling theorem here now. The sampling theorem says that the rate at which samples are taken should be greater than or twice the highest of frequency present in the input signal here. Now, whatever the sample signal we have taken, that should be greater than twice of the highest frequency. Whatever the input signal frequency is present, twice of that it should be greater here. Now, when the analog signal is not properly converted into digital, then there occurs an aliasing effect is going to occurs over there here. So some operating modes are there here for the digital storage oscillation. Operating modes are there. Those operating modes are three modes are there: roll mode, store mode, hold, or save mode. In the roll mode, what we are going to do, very fast varying signals are there displayed on the screen, that is going to roll over there. It is going to very fast रहते हैं, उसको हमने roll करके slow कर देते हैं. Next, store mode, we are going to store the value over there in the memory. Hold is there. In the hold or save, what we will do, we can hold. I have shown in the practical by pressing the button, it will be holds over there. It will not move with time. And then after some time, it is going to move with time over there. It is just to save the value. You can hold that one. Can hold that one. These three are there. How we can construct the waveforms here now? Whenever the horizontal plate, it is going to give the value, and horizontal, it is going to get the time plates, and vertical plates, we are going to get the input signals over there. So there are linear interpolation method is there. In the linear interpolation method, what they are going to give, just they are going to give the dot lines here. Graph ड्रा किए क्या कोई? अभी तो ऑनलाइन में ग्राफ का ड्रा नहीं किए अभी. Suppose I will give one table here now. So here, वो लूज है वो कनेक्शन इधर. वही सोच रहा हूँ मैं कैसे हो रहा है बोल. जस्ट हाँ बोलो ना. यस, कोई कुछ बोल रहे थे. So dots are joined by straightening the line. क्या बोल रहा था मैंने? See here, I will give one table here now. Here, time I will give time. For each time, what it will do, I will give the some efficiency I will give here now. For 1 second, efficiency will be 30. Okay. For 2 seconds, that efficiency will be 40. Suppose for the 5 time is 5 seconds, then efficiency will be 60. For 8, efficiency will be 90. Like that, I will give here. What you will do, you will draw a graph here now. Here you have to mention, that is time you have to mention 1, 2, 3, 4, 5, like that you are going to do that one. Here the frequency you are going to take 10, 20, 30, like that. Yes, ऐसा scale लेते ना? Yes or no? Like this will scale here now. For 1, how much is there? 30 is there. I will mark this one. I will take the dot first. Next for the 2, that is 40. I will mark this one. For the 5, it will become 60. I will mark somewhere here now. For that 90, I will mark that one. From 0 to, I will join later that one. Like that, in the linear interpolation method, what it is going to do, if the dots are joined by straight line here. First, you have to mark as a dot, it is going to mark. Later, it will dot to dot, it is going to join that one. The sinusoidal interpolation, what will happen? The dots are joined in the by a sine wave here. I will show here. Just a minute. आवाज आ रहा है क्या? Is it audible? Screen is visible? कोई तो रिप्लाई करो. हाँ?
Yes, sir.
Okay. See here. So without interpolation, what will do? These dots they are going to provide here, here dots are there, here dots are there. Okay. In the linear interpolation, what we have joined? This dot to this dot we have joined over there. See here. I will join from here to here. Next dot is here. Next dot is here. Next dot is here. And from here to here and here. Here, this is called interpolation. We are going to call it linear interpolation. Same, we are joining the dots. To sinusoidal, we have to do for the AC. We want the waveforms like this here. So what we have to do? I have to take the sinusoidal wave manner. We have to start from here, and we have to take like this. We have to move like this. The highest point we have to take as it is here now. Peak to peak value we have to set, and we have to take like this. बराबर है ना? See like this here. So that is called the waveform forming. We are going to call that one here. So next, what we will do? This is just for how it is going to form the from the after deflecting to the vertical plates and horizontal plates. How it is going to do that? Next, we are going to measure the frequency here now. Frequency measurement by Lissajous method. We are going to call that one here now. Or Lissajous method. We can call that one. I don't know how you are going to pronounce. Anyone, can you pronounce this one? Lissajous or Lissajous? Any one of you, please pronounce it. कोई pronounce कर सकते क्या? Roll number 4. Priyanka. 6.
Yes, sir.
Pronounce it fast.
Lissajous method.
Okay. So Lissajous method is there. In the Lissajous method, what they are going to do? One unknown frequency is there, one known frequency is there. Both we are going to compare that one here. That is called Lissajous method is there. We are going to identify. So in the oscilloscope, it is a sensitive indicator here. Now for frequency, it is very sensitive here now for the phase measurement. This frequency measurement by Lissajous method techniques used are very simple and dependable here. These are very simple and dependable. So one of the quickest method of determining the frequency, very quick method, we can call that one by using Lissajous pattern produced on the screen. It is going to produce the patterns like this here. I think you have studied in the physics here. I don't know how many of you know that. This particular pattern results when sine waves are applied simultaneously to both the pairs of deflection plates here. For the horizontal plates and vertical plates, when they are applied both simultaneously, and that we are going to get the, what is that one? Sine wave we are going to get. If one frequency is an integral multiple, that is called harmonics of the other here. One frequency is the integral multiple of other, the pattern will be stationary here. The pattern will be stationary, and that is called Lissajous figure or Lissajous method. We are going to call that one. So in the theory, you will not understand. I will show the diagram, then you will see here. This is the Lissajous method. Here, one side we have connected unknown frequency, another side we have connected the known frequency here. Okay, so just a minute. See here. Here it is there. So if the circle is there, it is also half is there. So FV is nothing but that vertical frequency equal to horizontal frequency. That is called vertical plates frequency equal to horizontal frequency plate. That is called, we are going to get a circle. See here, how many circles are there here? 1 and 2 here. So horizontal, this is increased, the width will be increased here. Yes or no? Exactly, it was single. Here it is double is there. 1 plus 1, how much it is? 2 here now. So whatever the vertical frequency equal to 2FH, we are going to call that one 2FH. So again, vertical frequency 1, 2, 3 we have considered. That is FU equal to 3FH, 4FH, 5FH. Like that, the signals will come. That is Lissajous method we are going to call. So instead of horizontally, it is increasing. If it is increased for vertically, means that is called, we can write F equal to 1 by 2 pH or FH equal to 2 FV. We can write both are same only, na? FH equal to 2 FV. Vertical horizontal frequency equal to 2 vertical frequency, or vertical frequency equal to 1 by 2 FH here. Both are correct or not? This 2 you send into here. FH equal to 2 FV. कोई तो रिप्लाई दे दो. Yes or no? So same it is there. So like that, FV equal to 1 by 3 FH or FH equal to 3 FV, FH equal to 4 FV, 1, 2, 3, 4 are there. Here 5 are there, FH equal to 5, FV we can write like that here. So like this, we are going to compare from vertical to horizontal. So actually the horizontal one is there, that is the known frequency, and vertical one is the unknown frequency we are going to call that one here. Which one applied horizontally, that is called known, vertically applied is unknown here. Now somewhere here I have mentioned that one. In this frequency measurement method, what we are going to do, standard frequency is applied to one set of deflection here. For horizontal or vertical, one set deflection को हमने standard apply किए, deflection standard set of deflection plate of CRT we have applied for the one known, and find the unknown frequency of approximately same amplitude is simultaneously applied to the other set of the plates here. So however, the unknown frequency is presented to the vertical plates. बराबर बोला ना, vertical plates को unknown frequency we are applying here now. For the horizontal, the known frequency to the horizontal plates we have applied here. So the resulting pattern depends on the integral of the phase relationship between two frequencies. The result output will be depending on the integral of phase relationship, that is horizontal and vertical here now. So the horizontal signal is designed as FH, that is horizontal frequency, and vertical signal is designed as FV here now. So first we have discussed the diagram and then we came back for the explanation here. So instead of that, see here, this diagram we have discussed. This is the method of frequency measurement we are going to call here. So the fractional frequency or relationship between the two frequencies, whatever the horizontal frequency and vertical frequencies, FV equal to fraction into FH. How, what is the fraction of that one? Double is there or half is there, like that we are going to consider, or FV by FH equal to fraction, that is called, fraction is nothing but number of horizontal tangencies divided by number of vertical tangencies here. Suppose I will consider this is here now. This one I will consider here. How many horizontal tangencies are there? How many vertical tangencies are there? Anyone, can you tell me? Yes. How many horizontal tangencies are there and how many vertical tangencies are there here? कितना है? हाँ? थोड़ा loudly बोलो. Loudly. See here, for the horizontal we are going to count like this. For vertically we are going to count like this. So vertically how much is there? 1 is there. Horizontally it is 1 and 2 are there. So 1 by 2 here now. 1 by 2. You can write this one. FU equal to 1 by 2 FH or FH equal to 2 FV. Both are correct only, na? So first horizontal we have to write. Just a minute. It is reverse way. It is not 1 by 2. It is 2 by 1. Horizontal, number of horizontal tangencies kitna hai? 1 and 2 are there. So that is called 2 divided by 1 here now. So FU equal to 2 FH. Yes, correct? Hai? So that is the fraction we are going to call here. Number of horizontal tangencies divided by number of vertical tangencies. So next one. Same diagram once again it is repeated. See here, for the whatever I have explained here just now, that diagram I have added here. Next we will go for the measurement of voltage here now. How we can measure the voltage here for the DSO here now. See, I will ask one question here now. Actually we have discussed here, this is okay. Suppose it is a graph is there like this. The graph is there. Here number of divisions are there here. Divisions hai na? Yes. So one division, I will take the different color here now. From here, I will start here. This in. Okay, like this I have considered. What is the peak to peak voltage here now? Can anyone tell me? See here, this is 2, this is 4, we are going to call here. And here, this is -2 and this is -4 here. What is the total peak to peak voltage here now? From here to here, how much is there? 4 minus of -4, it is how much it is? 8 is there, na? Total voltage. Okay. Total voltage 8 is there. Okay. I will tell that one. Peak to peak voltage kaise 8 kaise आने का चाहिए मैंने बोलता हूँ अभी. See here, a one division है. This is one division. One division voltage. How much we have considered? For one division, how much we have considered? 2 volts, na? Okay. 2 volts per division we have considered here into. How many divisions are there for peak to peak? Here 1, 2, 3, 4. 4 divisions are there. So 2 into 4, how much?
8.
8 here, no. So this is the voltage measurement method. It is going to do that one in the analysis, that is in the storage. It is going to display that one here. So the range of application of oscilloscope varies from basic voltage measurement and waveform observed to highly specialized applications here. So basic waveform measurement is different and highly application based is different here now. So from this peak to peak voltage, we are going to use this formula here now. Volts per division. Per division ko how much voltage is there and how many divisions are there? Number of divisions are there. Can you tell me what is the magnitude of the voltage? This one, this total magnitude of voltage, value of voltage. Anyone? On that condition, we should not concentrate peak to peak here now. From 0 to what is the maximum value here?
4.
4. 4 is the magnitude of the voltage here now. See here. The most direct voltage measurement made with the help of an oscilloscope is the peak to peak value. Okay, so the RMS value of can be then easily calculated from the peak to peak value. We can convert that one maximum value into √2, that like that RMS value will come over there. To measure the voltage from display CRT display, one must observe the setting of the vertical attenuator expressed in the voltage per division here. We can set this one per division voltage 1 भी set कर सकते, 3 भी set कर सकते, 6 we can set that one. Based on our setting, we can change this one here. So voltage per division and peak to peak deflection of the beam, we can also check that one here now. That is number of divisions here now. So peak to peak value of the voltage is then computed as here voltage per division volt, how much is that and how many divisions it has taken, that is called our peak to peak voltage here. How to find the time period? Suppose it is 2 seconds, 4 seconds, 6 seconds and 8 seconds here now. So the total complete time taken to complete one cycle, how much it is? 8 seconds. We can consider that one. Like that, one division equal to 2 seconds. So vertically we have discussed. The next part will come for the horizontal also here now. I will check it. See here. Next, period and frequency measurement here. How much period? What is the time taken for one division? And then we can, if the time period is known or frequency is known, easily we can compare with frequency because both are reciprocal to each other. We can measure that one. The period and frequency of the periodic signals are easily measured with oscilloscope. The waveform must be displayed such that a complete cycle is displayed on the CRT screen here. I will ask now, just a minute. I will take the red color instead of red color. I will take the white one. See here. I will draw only x-axis here now. X-axis I will draw here. 1, 2, 3, 4, 5, 6, 7 divisions I have made here. So 7 division. Each division I will use 2, 4, 6, 8, 10, 12, 14. I have used here now. Now I will draw the waveform like this from 0 to
shows the polarity which shows the voltage. Okay, we have applied the 230 volt. Here we have applied the 50 volt.
Now, can anyone tell me this x-axis is nothing but time here now? Time in seconds, I will call that one. To complete one cycle, how much time it has taken?
See the now
10.
10 here now. So this is the 10 seconds here now. For half cycle, it is considered 5. Here 4 is there, it is 6 is there. So 5 seconds it has considered. So total time consumption for the time period is 10 you have considered. According to this formula, we are going to consider. Per division को time कितना set किया? 1 division. So 0 to 2 is there, 2 to 4 is there. What is the difference here now? From one division to another division? 2 is there. So per division, we have set it, that is 2 per division, 2 seconds per division. Number of divisions per cycle. एक cycles को कितना divisions है इधर? 1, 2, 3, 4, 5. Here now. 2 into 5, how much?
10.
10. That is same. We got the answer here now. Yes. So without calculation, from direct by observing the waveforms also we can say that one here now. Yes or no? We can say that. Yes. So like this, we are going to measure the time period here now. So if the time period is measured, then what is the formula for the frequency? Frequency equal to 1 by t. 1 by t we can consider here now. What is the t equal to? Suppose 2 is there. So 1 by 2 equal to? That is 5. Yes. Like that, we are going to 0.5 is the frequency here now. The hertz we are going to consider, actually it will be there and the time will be in milliseconds is there. On that condition, it is going to get here 50, 500 also we are going to get that. T equal to, yes or no? Like that, we are going to measure the frequency and time period we are going to measure here. Any doubts here? Any doubts? Simple is there, no? The concept is very simple here. So almost here, the voltage measurement we told that one. Same, the current measurement also we are going to do. Current per division here and number of divisions we can add over that. That is for the current measurement, time period, and frequency measurement we have discussed. So it completes the 6th unit of your, what is that one? Oscilloscope it has completed. In the practical also we have discussed, I think. I will show the lab manual also. Already practical में discussion किए ना? शायद I will show the waveforms also. Just a minute. See here. This is the DC voltage. We are whatever the from the DSO it is going to display here. Where it went? See here. Is it visible? One second. और थोड़ा बड़ा करता हूँ screen. Visible है क्या नहीं? Is it visible?
Yes, sir.
Okay, see here. See, here the DC voltage is there. With respect to ground, we are going to observe that one here now. Suppose the scale I have given here, the dots they have given here now. See here, 1, 2, 3. Like that here, only one division is there. One division equal to 2 volt I have considered, means the DC voltage is, how much it is? Plus 2 volts we can call that. Plus 2 volts we can call that. For this one, comparing here the plus 2 volt is the DC voltage is there. What is what is the value of here? Anyone can you tell me? Here the ground is there, here the DC voltage is there. Yes. See here, I will tell that one. This is 0, ground is 0. Here 1 is there, here 2 is there, 3 is there here. This is DC value. So according to this, it is how much it is? 1 volt. 1 or not? Correct है ना? 1 volt है ना? नहीं है, और थोड़ा इसको 1 point something आ जाएगा शायद. वो डॉट के ऊपर है ना शायद?
आता काय
डॉटेड लाइन के ऊपर है और थोड़ा इंक्रीज करता हूँ 1 मिनट.
सिरीज मध्ये जोडायचं कशाच्या सिरीज मध्ये जोडावं लागेल समजा
स्क्रीन जैसा बड़ा कर देता हूँ तब इजीली समझ में आ जाएगा. यस, और थोड़ा इंक्रीज करेंगे. See here now. Now it is visible. See here, this is 1, this is 2, this is 3 here now. So according to that, 1 is here, 1 is here. So it is 1.2, we can say that one. I will say the value, DC value equal to 1.2 volt. Correct? Hai na? Yes or no?
Yes, sir.
From this one, I had written 1.2 volt. Anyone, can you tell the what is the value here now? This side. Another diagram hai na? Either DC value hai. What is the value of this DC value? Equal to what? Yes, fast. Here the x-axis is there. Okay. So here y-axis is there. This side positive is there, means what is the downside of that one?
Negative.
So why you are waiting then? This is the ground here now. We have taken reference as ground as a reference here now. So if it is positive, then negative here now. Here 1 we have taken here now, same for the each division. Here minus 1.2 we can write. Correct or not? Minus 1.2. That is the DC value here. Next, just a minute. See here, peak to peak value here now. Here 2, 4. That is 1 division equal to 2 volts we can consider. 2 plus 2, 4, 6, 8. Peak to peak we can consider. This is the peak voltage. The peak voltage is our total magnitude of the voltage we are going to call that one. For the sinusoidal waveforms here. The formula already I told. The observation table calculation, just a minute. Still it is there some values. हाँ हाँ क्या बोल रहे हैं आप? पूछो ना.
Assignment questions.
क्या बोले?
Assignment questions.
Here for the sixth one, 6 unit का क्या? So any 6 questions you write down from the assignment booklet. Any 6. Already assignment booklet is given. See here, this is the time period we are going to complete here now. From one cycle, that is called full time period we are going to call here. But here peak to peak they have taken here. Multiplying number of divisions from the step 3 here now. To complete one cycle, how much time it is going to consider? That is time period we are going to consider. So the frequency is inversely proportional to the time period. So it completes the 6th unit. So 6th unit is nothing but whole syllabus is completed now. If you want to ask any questions, you can ask regarding this. So only 2 chapter tests are remaining, chapter test 5 and 6. Maybe tomorrow I may conduct दोनों test एक ही साथ में conduct कर सकता हूँ. Okay. From after Mahashivratri, we'll start the repetition for you peoples with B division. Same link we are going to put in your group. You have to attend, all of you. Syllabus declare हो गए, खत्म हो गए, ऐसा नहीं है. So for the B division already classes are going on. So we'll start repetition for you peoples. Already section 1 is going on, 3rd unit is going on for them. You can attend the classes and you can attend for repetition for that one. So that is also attendance is compulsory for you peoples there also. Okay, so I can declare that the syllabus is over. If you want to ask anything, you can ask. Anyone you want to ask any questions, you can ask me. Yes. Any questions? Question nahi kya kunakad? No questions?
No, sir.
So assignment I will open just a minute. Assignment MCQ and assignment booklet, electrical measurement and instrumentation. The final assignment booklet. Okay. Still it is not yet opened.
जे तुम्ही किती पण ऍक्च्युअली जे रेग्युलेटिंग कंडिशन अशी सांगितली की तुम्ही इन स्पाइट ऑफ
See the all assignments you have to upload. I will tomorrow I will give the link. So for the upload the assignment, all assignments, Tuesday I will give the last date. All 6 assignments you have to upload of Tuesday. This is MCQ. I have opened the final MCQs. See 10 MCQs you write down first, then 6 questions you have to write. Any 10 MCQs you have to take from the out of 19, 18 questions are there. Use 10 MCQs you have to use for this one. Use 10 MCQs to write assignment and assignment booklet. Questions I will give just a minute. Long questions. See how many 22 questions are there. Explains in signal generator construction and working of the that sketch needs CRT का explain करो ये advantage of recorder here now. That is also not. ठीक है, any 6 questions you write down. 6 नहीं तो 5. Explain with need diagram working of general purpose CRO, that is general purpose CRO, whatever we have explained that one, and DSO blocks are there, that one you can explain. Any 6 are 5 questions लिखो, assignment MCQ questions 10 लिखो. 10 MCQ questions and 5 bigger questions you write down. Any 5 questions you write down and be ready for the what is that ISC 2. Soon the ISC 2 unit 4, 5, 6 is there complete. Syllabus for ISC 2 is unit 5, sorry, unit 4, 5 and 6. Okay. Next. Which push na hai? I am saying that one the syllabus is over, but you have to attend regularly for the backlog class sessions, but not backlog, that is repetition sessions. Which push na? So during in the March you have the exam, remember that one. Hardly 15 to 20 days is there. During this 15 to 20 days we are going to finish the syllabus. The tentative timetable for the second year exam is March 22. March 22. Tomorrow is only one day and another 20 days you will get the time for the preparation. Do the preparation well. Prepare for ISC. Don't lose a single marks. According to me, my suggestion is don't lose a single marks. Everything will matters. Your attendance, your assignment booklet, your lab book, your chapter test marks, ISC marks, all the things it is depend. Your ICA marks, term marks is depends on that one. And you have this subject practical oral examination is also there. We'll plan one day for that and we'll conduct the oral examination, which the syllabus for the oral means we are going to ask the question. For all 6 units we are going to ask the questions. On any unit we can ask the questions. Okay.
1, 6, 7, 8, 9, 10.
So I thank you one and all for giving support. So this ends the syllabus of electrical measurement and instrumentation subject. But after the completion of your thermos, POE and your examination, I will be continuing as your CC class coordinator for the further. But for second semester, we'll see that one. What is the plan for that one? If any subjects allotted to me, then we'll come for that one. Otherwise, we'll see in the next year, third year, final year, and all the things. Okay. Thank you one and all. I'll declare that one syllabus is over. Can I end this meeting now?